In Unit 3.1, we'll be talking about the periodic table and why it's so important to chemists. It's a very useful tool. You'll use it on just about every single test, and it organizes a lot of information about the elements that we know about. Dmitry Mendeleev was the scientist credited with creating the periodic table of elements. He was so important that the element 101 was named after him. It's Mendelevium. What he did was he looked for patterns in the properties of chemical reactivity of known elements. He put them in columns, vertical columns, based on similar properties. He also organized them based on atomic weight. As it turns out, the most important characteristic is really the atomic number, but Dmitry Mendeleev thought it was atomic weight. When he came across elements that had not yet been discovered, he left blank spaces on the table based on his anticipation that those elements would be discovered. On a few occasions, when the pattern of increasing atomic weight did not follow, Dmitry Mendeleev just assumed that the atomic mass had been calculated incorrectly. He truly did believe that atomic mass was the property that was important in organizing the elements. This all came about before we understood more about atomic structure, before we understood protons, neutrons, and electrons, and that the protons helped to identify the element. The current periodic table bases the elements on atomic number. What we say is that the properties of the element are a function of their atomic number. What that really means is that each element has its own unique atomic number, and the atomic number, which is the number of protons, identifies the element. The horizontal rows are called periods, and they're numbered 1 through 7. The vertical columns are called groups or families, and they're numbered 1 through 18. The older reference tables used an A-B numbering scheme, so if you ever look on the internet, you may see other reference tables with columns labeled 1A, 2A, 3A, all the way up to 8A, and then those middle columns that are short would be labeled 1B, 2B, 3B, so on and so forth. But the current table that we use, the one from New York State, has the vertical columns labeled 1 through 18. The periodic law states that when elements are arranged in order of increasing atomic number, there is a periodic repetition of their physical and chemical properties. Let me show you what I mean. If you look at lithium over here on the left side, it has certain properties. It's a group 1 metal, it's highly reactive, and it has 1 valence electron, and it tends to lose them. Over here, sodium is in the same vertical column, and it has some of the same properties as lithium. It's reactive, it has 1 valence electron, and it tends to lose it. That's why they're both represented in green. They have a lot of similarities. They're part of the most reactive family of elements. Beryllium and magnesium both have 2 valence electrons, and they both tend to lose both valence electrons, and their family is not quite as reactive as lithium and sodium, but they're still highly reactive. Boron has a lot in common with aluminum. They both have 3 valence electrons. Carbon and silicon both have 4. Nitrogen and phosphorus both have 5 valence electrons. Oxygen and sulfur both have 6. And fluorine and chlorine both have 7. So what we see as we move left to right is going from metal to nonmetal, and then the row starts over again with a metal working its way over to nonmetal. So the pattern keeps repeating itself, and I want you to notice it happens in groups of 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen is kind of outside of this pattern, and hydrogen's an unusual element. It really is kind of categorized in its own group. All right, we'll talk more about how the periodic table is organized in the next set of units.